question we are solving now belongs to test series 9. It is of control system subject. In specific, it belongs to root locus of the control systems. As per the question, the open loop transfer function of a control system is given as k by s square multiplied by 1 plus st1. We need to find this root locus of this control system. We know that from the properties of the root locus starts from the open loop poles, that is, it starts from 0 and minus 1 by t1. And also we know that the root locus ends at open loop zeros or infinity, whereas there are no open loop zeros, the root locus ends at infinity for the current case. And also the number of root locus branches is equal to 3, because the number of root locus branches is maximum of number of open loop poles and open loop zeros, which is 3 in this case. And also we can say that on real axis, root locus exists at any point if the number of open loop poles and zeros to the right of the section is odd. From this we can say that root locus exists on real axis for s less than or equal to minus 1 by t1. Also from the given g of s multiplied by h of s, we can say that the breakaway points of the root locus are located at 0. This can be obtained by equating dk by ds to 0 in the characteristic equation. So as to get this, first let us find out the characteristic equation, which can be written as s cube t1 plus s square plus k is equal to 0. Upon equating dk by ds to 0, we see that dk by ds can be written as 3s square t1 plus 2s plus dk by ds is equal to 0. This is upon differentiating the characteristic equation. So from this we get that dk by ds is equal to 3s square t1 plus 2s is equal to 0, which is dk by ds, which is equal to minus dk by ds. From this we can say that s is equal to 0 or minus 2 divided by 3t1. And from the given plot we see that the root locus may not exist at the point minus 2 by 3t1, hence 0 is a valid breakaway point for the root locus. From this data we can plot the root locus of the control system as shown. We have already written that the number of root locus branches is 3 and it exists to the left of minus 1 by t1 on the real axis, and as one of the breakaway points is located at 0, the root locus can be plotted as shown. And from the plot we can say that the number of root locus branches is 3 and they are ending at infinity as already marked. From this we can say that the correct option which represents the root locus of the given control system is A.